Okay, let's continue on multi-threading. So in the last slides, we talked about threads and the usage of threads and some details about threads. So in this slide, I would like to talk about a definition, basically, about two concepts. One is being multiprocessing or parallel processing, as you can see here, parallelism, versus another type of type of using threads, and that is concurrency. So very simple definition. Basically, when we talk about parallelism, we talked about multiple processes, let's say also threads, doesn't matter, the same thing, similar thing. But we have multiple processors, and each process runs on one processor. All right? So this is a multiprocessor or parallelism, parallel processing. A similar case, but a little bit different, is called concurrency. So in the case of concurrency, again, we have multiple processes, but we have one CPU, or our CPU has one core, better to say. So in this case, again, we may have the concurrency problem. We may have shared memory. We may have multi-threaded, and we may have shared access to the memory by multiple threads or processes. So this is called the concurrency. So concurrency and parallelism are almost identical, with the difference that in concurrency we have just one CPU. So the threads are alternated within the CPU. You generally using some scheduling techniques that you will learn about in the operating system course, that one process at a time uses the CPU. But I want to remind you that all of the problems related to shared memory and synchronization exist in concurrency too. It's just a terminology thing that when we talk about parallelism, we talk about multiple computers, multiple CPUs, and multiple processes. When we talk about concurrency, we talk about one CPU and multiple processes that use the CPU in a time-shared manner. So be mindful about these differences. All right, so we can say that whatever we talked about so far are preliminary distributed system programming. From this point onwards, we want to talk about practical or highly used distributed programming techniques. In other words, cluster programming. So we move back to the distributed memory section. We are not going to talk about shared memory anymore. The thread, we just introduced it for your information. Further details about it, we'll leave it for the operating system course. So we go back to distributed memory category, and we start talking about message passing, or more specifically speaking, MPI, message passing interface. So shared memory, distributed memory, and within distributed memory, we talk about message passing interface, or MPI. All right, so what is MPI? MPI is, in fact, a library, is a programming technique that implements message passing in a very efficient way. MPI is one of the mostly used programming techniques for distributed programming. It is relatively simple. I mean, in some senses, many people disagree with what I said, but in some senses, it is simple. In fact, it gives us some high-level programming instructions that abstract us from the details of socket programming. So essentially, when two computers want to talk to each other, we do not need to open sockets and close sockets and talk to streams. So all of them are abstracted in few commands or instructions. However, it does not mean MPI is simple. MPI is one of the most difficult programming techniques. I cannot say programming language because it's not an independent programming language. It's a library that is added to your programming language. So it's not simple really, because not because MPI is difficult, because parallel programming is difficult. However, it abstracts us from a lot of details, from a lot of unnecessary details that, for example, socket programming forces us to do that. Well, I want to mention that there are some other techniques apart from MPI. For example, there is another technique called PVM, Parallel Virtual Machine. But I would say, let's say 10, 15 years ago, they were competing to each other, MPI and PVM. But eventually, MPI got much more attraction, and many practical high-performance applications nowadays are in MPI. So if you want to join HPC market, HPC job market, MPI is like bread and butter. So you must know MPI. As I said, unlike PVM, which is an independent environment, MPI is not. MPI is a library that is added to your programming language. It is originally implemented for C, but nowadays there are variations of it for Java, Python, and other languages. Even in C, there are different implementations of it. One of them is known as MPI-CH. One of them is known as MPI-CC, and there are many other variations of it. Okay. So I would also like to remind you about a third category of programming languages known as distributed shared memory. So essentially, we have been talking about distributed memory and shared memory programming techniques. There is a third category somewhere in between known as distributed shared memory, which tries to combine the features of both sides and making some perfect programming that is as easy as programming on one computer, more like shared memory, but gives us the features of distributed programming, which enables us to go beyond one computer. Don't forget that shared memory programming, in other words, threads, are limited to one computer. You cannot go beyond cores of one computer. However, in distributed memory, you have a much more scalability, and you can scale to theoretically whatever number of processors you have. All right, so let me see what is left for message passing. Efficient, widely used programming paradigm and distributed memory. Okay, here is talking about this distributed shared memory. There has been some efforts on that, but we do not have, to the best of my knowledge, we do not have any product that can be used in production. It's more like in research, never came to practice in a serious way. All right, let's move back to MPI. So in MPI, as I said, we have multiple processors. See, these are different computers. Each one of these is a separate computer with its own memory. Look, this is a distributed memory. It's not shared. And of course, we have a network. So we have network, we have processing, and each processors and memory, all distributed, connecting via network. Okay. Yeah, I guess these are some preliminary information. Let's move on to more important information, about how to program MPI. So MPI is an example of SPMD programming style. SPMD stands for Single Program Multiple Data. In other words, in MPI, as an MPI programmer, you just create one program. So don't think that because it is distributed program, you have to create multiple programs. That is the abstraction that I was talking about. That is the benefit of using MPI. In MPI, you just develop one program as if it is a sequential thing. It is not, but it wants to give us the illusion that you are programming sequentially. Otherwise, programming in parallel would look even more difficult. Okay, now let's see how does one program be coded or be executed in a distributed manner. And our assumption in this part is C programming language. Although we do pseudocode for the most part, but our assumption is a C language because that's the default programming language for MPI. So as you can see, we have a main function here. All right. So then we have part of code that is written like this part. That is the master part of your program. And then we have a big else part. That is the worker part of your program. In other words, when you run this program, one of the processors, one of the machines will run this part, plays the role of a master machine, and all other machines play the role of worker machine. What is separating them is just one if command. So you determine using if which part of the program is the master part or the coordinator, you can call it, and which part is the worker part. So this is the bottom part, and you basically discriminate that using else. Okay, so MPI is a big community. There has been efforts since 1990-ish or around that time, and there's a big forum about that. So it's a big community. There are even books on just how to program MPI. So there's some benefits about MPI. It is portable, it is efficient, it is high level. As you noticed, you just need to program one, you develop one program, and then everything will be done automatically in terms of running it on the distributed system. So it supports heterogeneous parallel systems, and in the newer versions, it has some efficiency on the parallelism at the I/O level as well. So MPI 1, which is our default in this course, have around 115 instructions. So you can imagine that's like as big as an independent programming language. So it's difficult to learn that, and I mean there are so many instructions, and there is difficulty in implementing codes using MPI. All right, so now let's see how does an MPI program look like more specifically. In fact, going one step deeper than what we discussed in the previous slides. So first of all, you know, in C programs, we have include files, header files. Okay, so we have an include file saying to C program that, hey, we are using MPI. And then we have a bunch of initializations. So without these initializations, your program cannot work. And then we have some main part of the code where the communication happens between the different parts, and the main logic of your program is located in there. And eventually, we have the termination part where you say, I'm not going to use MPI anymore from this point onwards. All right, so I guess this is enough for this session of the class. I will prepare more slides and keep you guys posted. Thank you very much and stay safe.